Hi, this is Jessica Dunn, and today we're going to look at some practice problems concerning bond valuation. So the first question asks, is Complex Systems has an outstanding issue of 1,000 par value bonds. They have a 12% coupon rate. The issue pays interest annually and has 16 years remaining. So question A says, if bonds of similar risk are currently earning a 10% rate of return, how much should the Complex Systems bonds sell for today? Okay, so this bond has a $1,000 par value, 12% coupon rate, has 16 years till maturity, and the current market rate of return is 10%. So bonds of similar level of risk are earning 10%. So A. Let's first put this on a timeline. So this bond has 16 years until maturity. And we are wanting to know how much should it be priced for today. It has a $1,000 face value and pays 12% coupon interest. So remember, your coupon rate is what determines your payments. And so this is an annual bond because it doesn't state otherwise. So our payment is equal to our coupon rate times our par value divided by compounding frequency. So 12% times $1,000 divided by 1 is $120. So this bond pays $120 every year, and it also pays $1,000 at maturity. So since we've already calculated our payments, we know the future value is the same as the face value or the par value of $1,000. The discount rate is 10% because other bonds are earning 10% of similar risk. Now, some students get confused on this. They get confused on which percentage to put where. If it says stated rates or coupon rate, that is always what determines your interest payment. And another thing to remember is that you only use each interest rate once. So if you can identify one of them, then you automatically know the other. Let's see, and our N is 16 years because it's only compounded annually. So let's calculate the present value. Okay, so in my financial calculator, I put in 16 years at 10% with a payment of $120 and a future value of $1,000. Now both the payment and the future value are positive numbers because those are paid to the investor. So if you purchased a bond, the $120 per year and the $1,000 at maturity would go back into your pocket. So those are positive numbers. And then we compute the present value. The present value that you get will be a negative number, and that makes sense because that's how much you're willing to pay for this bond. So $1,156.74. So the answer would be that you're willing to pay, it should be trading for $1,156.74. Okay, so part B. What if the required return were 12% instead of 10%? So everything stays the same except our IY changes to 12%. Now looking at this, we don't actually have to do any calculations for this because any time that the required return is equal to the coupon rate, the bond is going to trade at par value. So the present value is $1,000. It will trade at par value. No calculations are necessary because the required return is equal to the coupon rate. So you don't have to do any calculations. A check for part 1 here. we see that the required return is 10%, but our bond is paying 12%. So our bond is paying more than what is required because of the market. So demand for this bond should be strong. And so if demand is strong, the price is going to be high. So the price should be over $1,000. So that's just a little cheat to see if you're in the ballpark for the right answer or not, because you can see that this bond is trading at a premium, which it should be because it's paying higher than market interest rates. Okay, so here is question number 2. Calculate the value of each of these bonds, and they all pay interest annually. So here we can just bust these out pretty fast. Bond A has a par value of $1,000, so the future value is $1,000. Our coupon rate determines our payments, remember? So payment is equal to coupon times par divided by compounding frequency. So it's 14% times $1,000 divided by 1, it's $140. It has 20 years till maturity, and the required return is 12%. So just looking at this bond is paying higher than market interest rates. So it should have very high demand, and it should be trading at a premium. But we can check that real quick with our financial calculator. So face value is $1,000. Coupon interest rate is 14%, so that's $140 per year. The discount rate is 12%, the required return is 12%, and it has 20 years until maturity. So I'm going to compute the present value, and I get $1,149.39. Okay, let's move on to B. B is really easy because this bond has a coupon rate of 8% and the required return is 8%. No calculations needed. It's going to be trading for $1,000. It's going to be trading for whatever the par value is, which is $1,000. You can double check it on the calculator if you need to. C, this one has a future value of $100. The par value is only $100. Let's calculate the payment, which is equal to coupon times par divided by compounding frequency. So 100 times 8%. So it has, oh, I'm sorry, it's 10%. Sorry, I looked at that wrong. So $100 times 10% divided by 1 is $10. It has 8 years remaining till maturity, and the required return is 13%. So just looking at this, this bond is paying lower than market interest rates. So demand should be low, and the price should be below par value. But we can double check that with our financial calculator. All right, our future value is $100. The payment is $10. Has 8 years left till maturity, and has a 13% required return. So I'm going to compute the present value. And yes, it trades below par value at $85.60. Okay, moving on to D. This bond has a par value of $500. Now, if your par value is not given, we can assume that it's $1,000 because generally they are $1,000. They may be more or less, but if it's not given, we just assume it's 1,000. This one is 500. Coupon is 500 times 16% divided by 1. Our N is equal to 13 years, and our required return is 18%. So here we see that this bond is paying below market return. So the coupon rate is 16% and the required return is 18%. So it should be trading below par value. But let's double check that. We have a $500 future value. The payment, see I didn't calculate it, but it's 500 times 0.16 divided by 1, which is $80. That's the payment. 13 years and 18% required return. Make sure I got that in there right. Okay, and I'm going to compute the present value, and I have $450.90. So the present value is $450.90, which is less than the par value of 500. Okay, and then for part E, it also has a face value of 1,000, just like the first few problems did. The payment is 12% times 1,000 divided by 1, so $120. 10 years till maturity, and a 10% required return. So looking at this bond pays 12% while the required return is 10%. Demand should be high, and it should trade for more than $1,000. But let's double check that. We have a $1,000 future value, $120 payment, 10 years until maturity, and a 10% required return. And yes, it's trading for a premium, $1,122.89. So that was just a quick exercise in being familiar with your calculators. Our next problem says that there is a bond currently selling for $955. It has a 12% coupon rate and a $1,000 par value. It pays interest annually and has 15 years until maturity. So calculate the yield to maturity. Anytime it asks you to calculate the yield to maturity, that is you calculating your IY. So let's put this on a timeline. So today this bond is selling for $955. So you could purchase it for $955. That's a negative cash flow. You take money out of your pocket and purchase this bond. It has 15 years until maturity. It has a $1,000 par value, so you receive $1,000 upon maturity, and a 12% coupon rate. So we first have to calculate our coupon. So our payment is equal to coupon times par divided by compounding frequency. So the coupon rate is 12% times $1,000 par value divided by 1. That's $120. So as the bond holder, you would receive $120 every year and $1,000 upon maturity. So let's put in what we know. So you're wanting to solve for IY. Oh, I forgot to put in years. Years is 15. So let's calculate our yield to maturity. Future value is 1,000. Present value is a negative 955. Payment is 120. We have 15 years until maturity. And I'm going to compute the rate. And we get 12.685. So that's a percentage term. This is our yield to maturity. Yield to maturity is, actually, I don't really like to write it that way. I like to write, let's see, your IY is equal to your R, your rate, divided by compounding frequency. In this instance, M is just 1, so R is equal to 12.685. So our yield to maturity is equal to R. Because if this had been semi-annual, you would have had to have multiplied that IY by 2 to be able to get your yield to maturity. It just only works this way because it is annual. Okay, so let's find the value of a bond maturing in 6 years. It's a $1,000 par value. The coupon rate is 10%. It pays semi-annually. And the required return is 14%. So sometimes this stuff is thrown in here. You don't really need to know any of that, except you do need to know that it's paid semi-annually. So it's compounded semi-annually. So let's calculate find the value. So we need to calculate the present value. So we want to know how much it costs today to purchase a bond that is maturing in 6 years. And receive $1,000 upon maturity. Now with this bond pays interest semi-annually. So twice per year you're going to get coupon payments, not just once. So it's 6 years, but there's actually 12 payments because there are 2 6-month periods per year. And so 2 times 6 is 12. So let's calculate the payment. Remember that is coupon rate times par value divided by compounding frequency. The coupon rate is 10% times the par value of 1,000 divided by 2. That's $50. So you receive $50 every 6 months for 6 years. And you receive $1,000 upon maturity. This bond pays interest semi-annually, so 2 compounding periods times 6 years gives us 12 payments. Our discount rate is equal to R divided by M, so our required return is 14%. Divide that by 2, and we have a 7% required return. So the future value is $1,000. The payment is $50. The present value is what we're solving for. We have 12 payments, and the periodic required return is 7%. So I'm computing the present value, and we get $841.46. So this bond has a value of $841.46. And that makes sense because it's paying below market rates. It's paying 10% while the required return is 14%. So demand should be low, the price should be below par value. Okay, here's another list of problems. All of these bonds pay interest semi-annually. So let's look at A. A has a par value of $1,000. It has 12 years to maturity, but that's semi-annually, so it's 24 periods. Has a required return of 8%, but we divide that by 2 because it's semi-annually, so it's 4. And our coupon rate is used to calculate the payment. So coupon rate times par value divided by compounding frequency gives us a payment of $50. So let's go ahead and calculate this with our financial calculator. Okay, we have a $1,000 future value, a $50 payment, 4% interest, 24 periods, and compute the present value. This bond is paying 10% interest while the required return is 8. So it should be trading at a premium, and we see that reflected here. So $1,152.47. Okay, for B, we see that this bond has a coupon rate of 12% and a required return of 12%. So no calculations are needed. This bond will trade at par value. The present value will be $1,000. Okay, let's move on to C. With C, the face value is $500. And face value, par value, and future value, these words can be used interchangeably. N is equal to 5 years times 2 periods. That gives us 10 payments. Our required return is 14% divided by 2, so that's 7. And we need to calculate our payments. Let's see, that's 12% times 500 divided by 2. So it should be $30. So $500 future value, 10 periods, 7% required return, and a $30 payment. Compute the present value. This bond is paying 12% while the required return is 14%. So it should be trading less than par value, which we see, $464.88. Okay, D. D has a face value of $1,000. It has 10 years till maturity, so 20 periods. Required return of 10%, so we look at the periodic rate of 5. And the payment is equal to the 14% times 1,000 divided by 2. So that's $70. So let's calculate that on our calculator. So $1,000 future value, 20 periods, 5% periodic rate, and a payment of $70. Compute the present value. So this bond is paying 14% while the required return is 10%, so it should trade at a premium, and we see that, $1249.24. And now E. E has a face value of $100, 4 years to maturity, so that's 8 periods. Discount rate is 7, and the payment is equal to the 6% times $100 divided by 2. So it should be $3. Well, let's calculate the present value. Okay, so I'm going to do $100 future value, 8 periods, 7% periodic rate, and a payment of $3. Compute the present value, and that gets us $76.11. And yes, this bond is paying below market rates, substantially below. It has a coupon rate of 6%, while the required return is 14. So $76.11. Okay. Let's assume that the Financial Management Corporation's $1,000 par value bond had a 5.7% coupon. It matures on, let's say, May 15th. We can change that, 2025. Has a current price quote of $97.708, and has a yield to maturity of 6.034. So looking at this, I really want to point out exactly how bonds are quoted. Bonds are quoted as a percentage of par. So 97.708, that's 97.708% of par. So we move that decimal, and we have $977.08. So it helps you to analyze bonds without getting bogged down by that par value, because you just multiply it by the par value to get the dollar amount. So anything below 100% is trading at a discount. So anything below 100.000 is trading at a discount. Anything above 100 is trading at a premium. The bond's current yield is equal to the current coupon payment divided by its price. So it's the coupon payment divided by price. So we first need to calculate the coupon payment. So 5.7% times $1,000 divided by 1. So same way we've always done it. So that's $57. So we take 57, divide it by the 977.08, and that gets us 5.83%. So the current yield is 5.83%. This bond's yield to maturity is 6.034, while its current yield is 5.83%. The yield to maturity is higher than the current yield because the yield to maturity includes some price appreciation. So from today until May 15th, 2025, the stock price is going to increase by $22.92. We know that because the par value is $1,000. So we know the stock price is going to increase because as the bond approaches maturity, the price of the bond increases or decreases. It converges to that par value. This bond is trading at a discount because it is trading below $1,000. Its price quote is below 100. Okay, here's our final problem. Let's calculate the value of each asset. Now, not all of these aren't bonds. These are just kind of a review for previous chapters. It'll help you for your test. So asset A, at the end of each year, it pays $5,000. So if we put that on a timeline, pays $5,000 every year for 3 years. We want to know what's its value today. This looks like an annuity to me, so nice and simple. We see that the future value is 0. It's 0 because, remember, the annuity assumes there's a cash flow every period, including the final period. So if it was more than $5,000 that last year, there would have been a future value, but that $5,000 is incorporated into the payment function. 3 years, and a discount rate of 18%, so we can calculate the present value. So $5,000 payment, no future value, 3 years, 18%, compute the present value of $10,871.36. That's the present value of this one. B is a perpetuity. From now until forever, you're receiving $300 a year. And the present value of a perpetuity is equal to the cash flow divided by that discount rate. So 300 divided by 15%. So $2,000. C, this looks like just a straight present value, future value problem. Here we have no cash flows for 4 years. And in the 5th year, we receive $35,000. So future value is $35,000. Payment is 0. 5 years at a discount rate of 16%. Let's calculate the value of this. Future value is $35,000. Payment is 0. 5 years until maturity. 16% discount rate. Compute present value. $16,663.96. $16,663.94. Okay. D says that in years 1 through 5 we receive $1,500, and in year 6 we receive $8,500. So there's different ways you could work this. I immediately want to put it on a timeline though. 1,500. Now you could recognize that 8,500 is the same thing as 1,500 plus 7,000, and then you could work this as an annuity problem. If you didn't recognize that, however, you could do this as a mixed stream of cash flows and use the cash flow worksheet on your calculator, the net present value button. But let's assume that you recognize it could be done as an annuity. That means the future value is $7,000 because I broke that $8,500 into two components. The payment is $1,500, 5 years at 12%. Let's calculate that present value. $7,000 as the future value, $1,500 payment, 5 years at 12%. Compute the present value. $9,379.15. I'm missing a year. This would be 6 years. I didn't think that number was right. So if I put in 6 years, my present value is $9,713.53. Good job if you caught that. So let's go ahead and add that in there. Year 5, 1,500, and year 6 is 1,500 plus 7,000. So we change this to 6. So our present value is $9,713.53. And then E is a mixed stream of cash flows. We have to put these into our calculator individually. So to do that, I'm going to use our cash flow worksheet. So I push cash flow and then second, clear work. Cash flow at time period 0 is 0. So I push enter and the down arrow. At time period 1, it's 2,000. I do have to push enter to save, and it tells me that up here at the top of the screen. So enter. Notice it's saved because now there's equal signs. Down arrow. It's asking me the frequency of that cash flow, and it only occurs once. Cash flow at time period 2 is $3,000. Enter to save. And now I'm going to scroll down. It only occurs once, so I'll scroll again. Time period 3, it's $5,000. Enter to save. Scroll down. Time period 4, it's $7,000. Enter to save and scroll down. Time period 5, it's $4,000. Enter to save. And time period 6, it's $1,000. Enter to save. You then push the net present value function. Our discount rate is 14%. Enter to save. Down and compute. $14,115.27. That's it for these problems.